Hello everybody, welcome to section 9.6, and we're going to be talking about some applications of quadratic functions this time, slightly different than some of our earlier applications of quadratic equations. In this case, we're dealing with the shapes of parabolas, functions that are formed by parabolas. And one of the things that you'll notice about all of the parabolas that we've looked at is that they all have maximum or minimum points. And if we can find the vertex of the curve, this is going to allow us to use this notion of maximum and minimum to help us solve other applications that it might involve them. And so we'll go through a few of those applications here in this series of videos. The first one, let's just talk about a really basic function and say they ask, let's find the maximum or minimum value of the function f of x equals negative 3x squared plus 2x plus 1. How should we go about that? Well, if you recall, one of the things that we were able to establish back in the last section was that we can find that the vertex of a function given of the form f of x equals ax squared plus bx plus c is always given where we have a coordinate at the point x is equal to the negative of b divided by 2a, and then the value of y at that coordinate point. So f of negative b over 2a. Now we could go through and we can also complete the square and any other number of items right here, but let's just go ahead and just apply this formula to our function. Y is equal to negative 3 times x squared plus 2x plus 1. And if we use our formula, we're going to say that the vertex, the x-coordinate of our vertex will be at the negative of b over 2a. And in this case, a appears to be negative 3, b appears to be 2, and c is going to be 1. So making the substitution into this equation gives us the negative of 2 divided by 2 times negative 3. And of course, that's going to turn into positive 1/3. All right, so what we want to do if we want to find the actual maximum or minimum value of the function, we actually need to find the y-coordinate that goes with that. So we actually have to find f of 1/3 to see what's going to happen. So we're going to substitute that into our function and find, well, negative 3 times 1/3 squared plus 2 times 1/3 plus 1 should give us that particular y value. We're going over here to x equals 1/3 on our graph. And what we're really interested in is what is this y value that goes with it. Okay? In other words, 1/3 something is the location of our vertex. 1/3 comma something. So we want to find out what that something is, because that is considered our maximum value. Well, in this case, that would be negative 3 times 1/9. 1/3 squared is 1/9 plus 2/3 plus 1. Well, simplifying a little bit, negative 3 divided by times 1/9 is the same thing as negative 1/3 plus 2/3 plus 3/3. Well, working our way left to right, that's 1/3 plus 3/3, which is to say 4/3. And as a y value, that's it. So we would say that our maximum value of the function is actually the y value of the coordinate 1/4. There we go. 4/3 or 1 1/3, right? that's where the maximum of the function occurs. And when we ask for a maximum, that's what we're actually asking for in this function. Okay, more to follow in the next videos.